Okay. So, thank you, Jacqueline. I was asked to speak about natural processing on the web. So, what I will talk about is I will try to define what I see very briefly of what is natural processing and what NLP does for the web and what the web brought to NLP. So that's the idea of what I want to talk today. So what I see as NLP, so it's natural, NLP is natural language processing. So the idea is to help computers and people to interact. So it is a very old goal because in fact as soon as computers appeared, then there were people who were trying to use them and to ease it. The most natural way of interacting with people and with other systems and even animals is talking to them and writing to them in a language that we all know. So, and in fact, so NLP started that way, and it is still continues. It continues today, and it is very active. And in fact, with the web, we'll see that it is becoming more and more active. So I will argue today that, in fact, NLP is essential for the web, and also that the web is essential for NLP. So NLP, in fact, combines many things. It combines computer science, because we want to have the computers to talk, so we need to program the computer so that it understands the language. It combines linguistics, because linguistics is a science that has been going on for many centuries, and talking about how the language is structured and how we can define and help to understand each other, so that the language has an internal structure that we have to share between people so that we can understand each other. So linguistics is this science that tries to organize these things or understand how it evolves. Sometimes it is more formal, or sometimes it is more descriptive. Sometimes it is more prescriptive, so you have to write this way. And also it mixes some cognitive science, because language is essentially a cognitive process. So it is very important. So NLP is in fact a combination of all those things. So, and to simplify roughly what I see, because it is very hard to there are two main NLP approaches. What we can call as rationalist, which means that we try to model the language process through, say, some kind of manipulation, symbol manipulation. So it builds on the idea that most humans are born with some kind of language proficiency. So, and in fact, people can manipulate symbols. So if we want to have computers to try to do this, to speak or to understand the language, the usual language that we have, is that we must, or we will try to model it using some kind of symbol manipulation. So this is one approach, and I've said 19. So this approach is the first step in AI. So the AI more or less started with this approach, with symbol manipulation, with people like Simon and many others, and it is still going on. But at the same time, there were other people who said, well, that's not really the way, that people don't necessarily are born with a language capability. It is more of say pattern recognition, inference, generalization. So this is the way that people. So this is how, say, young babies and young people, they don't learn the language. They are born with a way to, they learn to learn the language. And that's one way. So in recent years, especially because now we have more powerful computers, we've going. So there has been plenty of work in the area of statistical and machine learning approach. But I'm not saying that it is either one or the other. In fact, it's probably a combination of the two, and NLP in fact combines the two. And I will give some examples of things that combines both the symbolic approach and the machine learning approach. Because sometimes we know things, so it can be much faster to know the things in advance than trying to learn them from scratch. But there are plenty of ways of plenty of work that go in both ways. So here are some classical applications of NLP. So the first thing we can imagine is that you would have a computer that tries to understand a sentence, and one way of trying to understand a sentence is try to find the structure of the sentence. This is called parsing. So you want to say, well, where's the verb? The verb indicates the main action, and who does the action? The action is done how. So you try to find relations between words in a sentence. This is what we do when people speak and we understand what the others are saying. So this is one classical application of NLP, and there are plenty of ways of doing that, both statistical or symbolic ways of trying to understand each what are the components, say, of a sentence or an utterance. We can also see natural language generation. Well, the idea is to go in reverse. So you have some information in the computer, and, well, it's nice to have information in data structure and everything, but the idea is that you should convey this information to the human, so that it can be understood by the human. So you have to generate the information. So generating the information is in fact usually in two steps. You have to decide what to say and how to say it. In fact, the hardest part, in fact, in natural language generation is what not to say, because usually you have plenty of information, small details, that are not really important, because otherwise you will submerge the auditor with too much information. So you have to select, organize it. So this is the hardest part in natural language generation. So this is a quite active part in NLP also, which usually is not so well recognized, but now people are have been working in this area for quite a long time, but now you have industries and companies who are working in this area and doing very interesting work, especially when you have, now everybody is talking about big data, but if you have big data, then you must summarize it in some way and convey the information. So this is one important part. You also have, well, spelling and grammar checker. So those are also classical things that are now so well embedded in every text editor that people don't really even realize that this is NLP. This is only a menu item somewhere. But this is the informations that is needed to do spelling and grammar checker is quite, it can be, is very hard, and now it is always been it's now well embedded. So you as soon as you type things, and you don't even need to type everything, it will try to guess. Those are all things. Those are NLP, in fact. Other things that are done in NLP are, say, automatic summarization. So if you have plenty of text, say many texts that talk about the same events or that are related, but people want to know what is the important thing. So you have to remove the things that are less important. So this is quite important, say, for security, when you have so many news feeds, but many of those things are either redundant or things that have been already said before. So you have to select what is the most important, and what is also new compared to what people already knew. So this is one area which is very active also. You have also machine translation. Machine translation has been, in fact, one of the first motivation for natural language processing. In fact, natural language processing started, say, as soon as the computer were there. In fact, you were in the Cold War, and there were between Russia and the United States, people, each country wanted to understand what the other was saying in their own language, so they could not translate everything, so they tried to use computers. And in fact, machine translation was seen more or less as some kind of decryption. So they were considering more or less, say, Russian as bad English or encoded in English. So this area is also very well developed. Especially, I will show some example later. But now, you have that on almost for free. People are using that in their own, and they're using, say, Google Translate to translate almost any web page or something like that. So they take this for granted, but it is not a solved problem yet. Also, information retrieval, where when you have so many documents in which you must find the important information, then this is called information retrieval. So it started when people, as libraries, where they were indexing. You've had the indexing cards for many years, but now that you have so many documents, and especially as I will show later, we will need to. There's a need to find the right document. So the problem is not to get the document, is to get the right document. So the information, we have plenty. In fact, we have too much. So we have the goal is to select the important information in there. And also, for example, speech recognition is also a part. An important part of NLP, because it is usually the most natural way to interact with somebody, is to talk to that person. So if we want to interact with the computer, we should be able to talk to the computer. And there are still many problems in there, but now, as we've seen for many smartphones, you have that more or less embedded in different ways, and for many restricted domain, it works quite well. So those are some of the application of NLP, and with that, we've been working in this area for a few years now, and we have a lab, which if you're interested to see what we're doing. So it's called RALI, which stands for Recherche appliquée en linguistique informatique, which means applied research in NLP. So we're three professors and with about 20 graduate students and working in more or less some of the subjects that I've talked about. So first, I will, now that I've given you some idea of what is NLP in general, I will come back to the subject of talking about NLP for the web. So NLP for this, so as you know, I'm sure you've heard this over the last few weeks, that we can divide more or less the web between the syntactic web and the semantic web. So we will first start with the syntactic web, that is the web where people write more or less text, and then after that, well, we have to get the information. So in a way, I like to say that more or less NLP saved the web, because, well, I was lucky enough to be there when there were so very few web pages, when the only way to get the information, to find the information, was to save your own bookmarks. And we had a list of bookmarks. People were building more or less list of bookmarks with the Archie and all those things. But in fact, as soon as people started to go on the web and write billions and billions of pages of web page, finding the interesting web page was very challenging. So the idea was that people started to parse those pages to find the interesting things. So this is how information retrieval started. And in fact, the search engine were in fact more or less an accident. Well, they would have happened sooner or later, but they started first as a demo. Well, there was that digital equipment at this their new kind of computers, and it was very powerful for the times, and they were looking for an application for a demo to show that that the computers were very fast. So they started, well, we will get the web was starting, so we will try to find new web page, and it happened like that. And everybody saw that it was very useful, but at the core it is NLP, because you have to. There are plenty of. You have to analyze both the documents and the query. So this is. I don't know. Do you see? No. Okay. So I will go this way. So, in fact, this is some kind of way of how a web and search engine works. Okay, so you see, there are things that are done offline here, and there are things that is when you start, you build more or less a list of web page. You build a big index of all the web page that you can have, and then when you search for something, so you type something in the Google search engine, then you start what is over the line here. So, but there are plenty of work, and all this is done in a very few seconds. So there's NLP, but there's also quite a lot of fancy engineering and data structure, and they are. So it's quite an endeavor to see that this thing can work. So in fact, what happens, more or less? So you have more or less the web. So you have web page that people write here and there. You have systems that write pages also. And then after that, so you must crawl them. So you must find them. And you start from a few links, and as the pages are linked together, you follow links. There are plenty of algorithms to go like that, and you have to get some pages, and then you have, and in fact, one of the main problem of those things is to remove duplicates, for example. So you can have many different links that go to the same page. So it's important. So once you found pages, you have to parse them. So parse them is, for the moment, it's usually only getting some words, strings of characters. So this is very basic parser, but it seems to work. And you have to differentiate between links, and then you build more or less link. You build link between the pages, and then there's a link analysis, more or less. If many pages go to the same pages, then it seems that those pages are important. And especially if the link come from important pages. So this is what is called the page rank analysis. Okay, so this all involves. So when you have that, you do the analysis of the links, and then you build indexes, and then after that, you have all those data structure, and as soon as somebody types a query over the top, you must try, you do some caching, usually because most of the queries are always the same. Okay, so FIFA to 214, this is already in cache, you don't do, it's already pre-computed. So this is engineering, but this is what makes the thing work. And then after that, if this is a new query, then you must go to the index and search for all the pages that more or less seem interesting for the query, and then you have to rank them. So there are plenty of algorithms, because usually most people only look at the first or the first few results that are returned. Okay, so all this. So if you look at this, you have NLP built almost everywhere, because in fact, what is the so what I argue is that NLP is essential for the web. Okay, it's essential because most of the information on the web is in human language. It is not necessarily written by humans. There are plenty of web pages that are generated either by natural language generation or by simple scripts. But the information is in human language. But in fact, humans are not the main clients for the web. Don't know if you know that, but in fact it seems that humans account for less than 40% of the web traffic. So what they've done more or less to get that is that they sample, say, a billion visits on 28,000 websites, and then they look at who was coming, because as soon as you access a web, usually you can guess if it is a human or it is a robot, or this can be faked, but on this scale, I think it gives you some idea. And in fact, we see that human traffic is about 40%. Search engine are about good bots, so it means that robots, but they are good robots that say try, for example, to look at pages or scrape things but they are also people or systems that go on the web just to try to find things, and So and this accounts are almost for 30% also. So you have malicious non-human, good non-human, and human. So in fact you have about I would say 70% of a good web and about 30% of strange things. But the idea is that, so we see that, in fact, the information on the web is written in human language, but the clients are in majority non-human. So this shows the importance of having NLP for the web. So if we look at now where NLP goes in the semantic web, so I think you've seen this figure or this tower or this pyramid many times. In fact, you'll see that the semantic web is based on two main things, on many things, but especially on XML, on RDF, on ontologies also. So I will arc here, I will show where NLP goes for those and help organize, in fact, the semantic web. The semantic web is used by robots. It is mean that it will be used by robots, but the fact also is that so we will need to combine all those things to obtain the information. So first for the XML, because if you know, well, RDF, XML, RDF, and all are things that people don't want to write. Those are things to do. They are XML was designed to be written and read by computers. But as people continue, they want to continue reading and writing, so we need some way of taking the information from humans and putting it in XML. So one way is that you must tag the information in XML, and this usually the information that is put on a web page is aimed at people, because if you see, usually what you have, if you have an HTML page, for example, a very simple one, the human will see this. Okay, you will see that there's a title, an author, publication date, then there's interesting content, some tags about the content, and say perhaps a copyright. But in fact, when you parse this with the computer, what you have is that you have more or less an headline, you have here italics, it's bunch of characters, some links all together. So the idea is that we should try to tag this into this. And in fact, people will write this, but don't want to tag explicitly each thing. So what we need, NLP will help to bridge this gap between the two. So one way to bridge the gap is through some kind of annotation. So we will try to use NLP to annotate the information. So it will go through those pages and try to find and tag semantic information. So that's the goal. And it does that through, say, named entity recognizer. So we must try to look at things and say, well, this is Université du Québec à Montréal. This is one entity, not a bunch of four words or strings of characters. So this is one way, and you have to recognize dates and numbers and link things between the two. So those are this is NLP for the simple things. So this is the basic thing we have in, for example, this is the basic thing here. Okay. Now we will look at how NLP can help for RDF. So RDF, just to recap, is the fact that it's a very simple data model that links a subject and an object with an arc. So it's a simple graph, and the subject, the object, and the arc usually have a name, and it's supposed to be a unique name across the whole web. So there are plenty of ways to do that, but this, you cannot expect people to type that. So people will write things, and then you will try to identify what is the subject, what is the object, what is the link between the subject and the object. And also what is very important is that when every occurrence of the same subject should have the same name, because that's the only way to make links between things. So this is quite difficult to find, so that every subject, predicate, and object must have exactly the same name. So you have to link, do some kind of entity linking, which is a very hard problem. Because now, well, there are even some challenges or some contests where people try to map, say, information in some text to entities that are known. For example, if you want to find, say, Stephen Harper, so it should be the Stephen Harper and different than many others. Okay? So, for example, if you have with Stephen Harper, it's relatively simple. With Barack Obama, it's relatively simple. But when we have, for example, Bush, Bush is also a common noun, and there are plenty of American presidents that were Bush. So you have to differentiate between them. So it can be quite complicated. So the idea here is that usually this is called the KPB, it's knowledge-based population problem. So the idea is that you take text, running text, say news feeds and things, and try to identify the entities in them, and then try to find the links between them. And all the entities that speak about the same thing must have the same name. Okay, so when you have that, then you can start to do whatever the semantic web is supposed to do. You can check things, you can find new things, you can do some inference, and this is and to do all this, you need to solve the kind of the problem that I've given here. So, for example, word sense disambiguation, event detection, sentiment analysis. So you want to see what people are talking about. And also for NLP for the semantic web, so for ontologies. So ontologies are also very important in semantic web. So in ontologies you have to find the individuals. So for example, John, Mary, this table, and you have to find classes. This is set of people that share some property. And properties that link individual to classes, or usually to individual from they link individual that are put in classes. So NLP can also be used for that. So there are, for example, there's you can do NLP either to build if you have an existing ontology, you will parse the text and add information and add, populate, for example, the ontology with information that is found on the text. They can also, this is a bit more difficult, but it can also be used to create an ontology. Okay, so for example, you will try to find some basic entities, and then you will parse the text to find the link between the entities. So that will give you some dependencies between the entities that you have found in the text, and then from that you can extract some properties. Okay, so this is one way. This is very fast here, but it gives you some idea that NLP can be used for the web. So in fact, for the web, if we can recap that, is the fact that it is essential, okay, for the web. So the web would not be the same if we didn't have NLP, and it is often not recognized as such, because I've been working in NLP for many years, and quite often people say to me, well, when will that thing works? And in fact, I tell them, well, when was your last Google search? They don't realize that they're using NLP. And in fact, it's like any work in AI. AI will never work, because as soon as it starts to work, they call it engineering. So we will always have this problem. And so now I will take the opposite view and say the web for NLP, because what I've argued is that NLP is very useful for the web, but the web is also very useful for NLP, because it gives us an access to an infinite corpus of text in many languages. And there are many interesting facts about language that can be found on the web. So, for example, Wikipedia, DBpedia, Wiktionary, those are all nice resources that can be used to do good applications. So, for example, language models. So this is quite important to develop statistical approach. You need language model. Essentially, a language model is a table of properties. So if you have say unigrams, you compute how many times such a word happens. If you have bigrams, how many sequence of two words happens together, trigrams, and so on. So you can do that on words, on characters, but you need, so that those things work, you need plenty of text. And with the web, we can get plenty of text. So you have example here of text that can be found on the web, such as the trillion-word corpus made available by Google, Canadian Answered, which are ways of text. So you have text in both French and English, and you can compute relations between two languages. You have that also for the European Parliament. So, for example, if we use unilingual language models, so language model in only one language, okay, so this can be used to do some kind of document classification. Okay, so we can compare, you build a model for some type of text. So, for example, blogs and things like people, document that talks about a certain subjects and so on. So, and then you build a language model of those, and then when you receive a new text, you use this language model to find the language model which is closer to the language model of your text. So this can be done for document classification, for information retrieval. So it is also quite often done. You build a language model of set of documents, then you try to match the query, the language model of the query, with the ones of the document. It can be used. You can also use that for language identification. So this was one of the first application of language model. To try to you take a sequence of characters and then you try to guess the language model, the language from which this sequence is done. We do that every day. You use that; it's very well used. We can do that for adding accent. The acritic marks in French, for example. We have a small example like that. So, for example, if you have a French text here, in which, well, my people don't like to type strange diacritic characters, so we have a program that is based on a language model that will return you that. And what is interesting here is that you see that accentu, those are exactly the same words, the same characters, but the system managed to find the right things. And usually it works quite well. It's one error on average every 200 words, which is probably better than what a human can do, because this is quite boring to do. We can also use bilingual texts that are found on the web. So for that, we use, for example, a bilingual condenser. So for example, if we look at the languages that are on the web, in fact, you will see that, in fact, English is almost everything is in English. And then after that, all the languages are. So when you have a bilingual site, usually one of the languages is the English. So, and for example, what we've done in our lab is a system to find. So what we have is say all the Canadian inserts, which are the transcripts of the Parliament hearings, and that are in Canada, that are always produced in both languages. So in fact, what is here, when it is in gray, it means that the original was, say, in English, and this is the translation. And the interesting thing about those answers is that the quality of the translation is very good. Those are human of high quality, so it can be a way. So, for example, if you want to try to translate kettle of fish, which means nothing in French, so you must. What we do is that we find all pairs of sentences where we have kettle of fish in one on one side, and then after that we try to match with a corresponding thing. So you have here boîte de Pandore, paire de manches, passe aux vraies affaires, and so on. So this is one way of using the information for NLP. Okay. We also have we can use Bible text to develop develop machine translation. So the idea is that we try to find the best way, and usually it is based on two types of language. So you have the translation model. So how often is some kind of strings of characters translated or found in a corresponding sentence? And also we use the language model to smooth that. So just to give you a rough example of what does that look like. So it means that, for example, we've parsed or we've accumulated statistics on plenty of text, bilingual text, aligned bilingual text. So we found that have not been démocratiquement, n'ont pas été démocratiquement, and you have some kind of parameters and probabilities associated with each of those things. But those tables are very, very huge. Okay? And in fact, those are what we call phrase table. In fact, they are not all, this is nice. Those look like nice phrases, but usually it can be is an absolute must. That's quite good, but quite often it can be strange phrases and something like that. So this is how to compute that, and that's usually how machine translation works. Is based on the combination of the information found this way and also on the language model. So they must stick together things and then compute the best way of sticking together all those phrases and map them and smooth them with the language model. So we've done some work in our lab on translating, say, weather warnings. In fact, in Canada, everything must be both in French and in English, and must be made available both in French and English. And, well, the weather bulletins are generated in both languages, but the warnings are written in both. So, in fact, so the web for the NLP for the web, so in fact, I have given you a rough idea of how machine translation can be worked. So machine translation for web page is using the information that is gathered from web page. Now Google has to be very smart, because quite often it cannot learn from its own translation, because otherwise it will so they must check that. And it can be used also for ontologies for helping users. And for example, you have speech recognition, which are also based on language models that are used. So in conclusion, we can say that the web would not be the same without NLP, and NLP would not be the same without the web. Merci.